The rice husk, also called rice hull, is the coating on a seed or grain of rice. It is formed from hard materials, including silica and lignin, to protect the seed during the growing season. Each kilograms of milled white rice results in roughly 0.28 kilograms of rice husk as a byproduct of rice production. During milling, it was reported that the amount of rice production globally had hit 501 million tons, involving more than 160,000 hectares of harvested area in 2016. By comparing the South Asian countries as presented in, Malaysia has a relatively small production of rice as it only covers 0.21% of Malaysia's land area, a significant increment of 56% growth rate in paddy production was predicted between year 2002 and 2022. Burying the husks left no room for the rest of their crops to grow, and burning the husk presented an even bigger ecological problem. The burning of the husks also causes larger problems for nearby wildlife. The fires are quick to catch and destroy the surrounding nature and can prove dangerous to any of the populace that live in the area. It poses an incredible danger to the environment, harming the land and the encompassing zone where it is unloaded. Utilization of no beneficial rice husk ash as supplementary cementitious materials with pozzolanic properties has been adopted in construction industry nowadays. It bearable to overcome the environmental issues globally and provide comparable strength and properties as conventional cement. The rice husk was placed in alumina crucible. Rice husk ash was produced by incinerating rice husk in a furnace with a controlled temperature of 650 degrees Celsius at 1 hour soaking time. The ashes were ground and sieved to collect only 63 micrometer size particle. The advantage of rice husk ash is it imitate the conventional cement characteristics. The results show that rice husk ash contains high siliceous content and the ashes contain mostly amorphous silica phase. This rice husk ash is categorized as Class N pozzolanic materials comply with ASTM C618. The amount of RHA, OPC, fine aggregates and water required for the cube mold with a dimension of 50 by 50 by 50 millimeters was calculated. The mortar that was mixed with RHA at different compositions between 5 and 20% to be used for comparison. Water to binder ratio demand was set at 0.44. All the mortar mixtures were demolded after 24 hours and then water cured for 28 days. The mortars were heated up to 1093 degree in an electric muffle furnace by following the ASTM E119. This test method provides a standard time temperature curve to which materials and components are exposed to evaluate their resistance to fire. According to this invention, there are no spalling and cracking occurred in rice husk ash replacement mortar when heated to 1093 degree. In addition, high residual strength was recorded compared to conventional cement mortar. Surprisingly, greater sustainability analysis in two different categories were recorded for rice husk ash replacement mortar compared than conventional cement mortar. In conclusion, cement with RHA replacement poses good fire resistance characteristics and has potential to be used in construction fields. The utilization of RHA as supplementary cementitious materials solves the problem of its disposal, thus keeping the environment free from pollution.